Okay, before we get into this lesson on simplifying expressions using the exponent laws, let's just review our big exponent laws, right? So, because we're going to be using these a lot, and when I say, the product rule or product law, like let's say x to the power of a times x to the power of b, if they have the same base, we can add the exponents, right? And our quotient rule, if we are dividing x to the power of a divided by x to the power of b, we can subtract the exponents. And our power of a power law, if we have x to the power of a to the power of b, right, we can multiply the exponents, a times b. And then if we have a negative exponent, so x is, let's just say that a is a negative value. Well, this could be 1 over x to the a. And same thing if I want the inverse of that is, what if I have 1 over x to the negative a, I can flip it to the top and make it positive x to the a. And then our final rule we were talking about was, remember, and we'll be using this a lot, if we have x to the power of a over b, right, we can write that two different ways. We can make it as x to the power of a, right, first, and then do the b root of that. Or we can do the b root first of x and then do the entire thing to the power of a. So those are all the exponent laws you really need to know, and right, so I'll be using those a lot as we go through. Okay, so at the top here, just to recall a little more, I got that rule I just talked about. Remember, the top number of that rational exponent is like a regular exponent. You're just treating it the same. The bottom value on the denominator is the index of the root, right? Second root, third root, right? So on and so forth. So let's just review really quickly a few quick examples, right? If I have something like negative 8 to the 1/3, that means what's the third root of negative 8 to the power of 1? So we don't have to worry about that. You could write it like this, to the power of 1, but it doesn't matter, right? Because it's just going to be whatever the value is. So the third root of negative 8 would be negative 2, because negative 2 times negative 2 times negative 2 gives you negative 8. All right, let's look at one with a little more complexity. Again, I got one here. It's got a negative exponent. So the first thing I want to deal with that is probably to flip it, right? So we can rewrite this as 1 over negative 8 to the 2/3. Okay. Now, what did that mean? Let's break this down using the top and bottom of that rational exponent, right? So the 3 on the bottom of that tells us we want the third root of negative 8, and the 2, the top number, tells us we want to square it. So we already just figured out from our previous question that the third root of negative 8 is negative 2, right? And then negative 2 squared is 4. So this is 1 over 4. Now, this one here, this is getting into kind of what we're doing today. The main thing is what the work we're doing up in the exponents. So let's think about this here. I have 8 to the 5/6, right? Now I can rewrite this as times 8 to the 1/2, right? All divided by 8 to the 5/3. Now, what are we going to do with all these? Well, let's use our exponent laws. What do we do when we're multiplying? We can add the exponents. And then what do we do when we're dividing? We can subtract the exponents. So I can just do this all at once and make it, they all have the same base of 8. Okay, so 5/6 plus 1/2 minus 5/3. So I just get a common denominator here, and it's going to be 8 to the, what do we have here? 5, let's just put it all over 6 here, right? Times this by 3 plus 3 times that by 2 minus 10. And what do we have here? 8 to the, what do we have there? 8 minus 10, right, is a negative 2/6, which we can reduce. All right, let me just bring this up here. So that's 8 to the negative 1/3, right? Well, what do we do with the negative exponent now? Now that I have a negative, I'm going to flip it to the bottom, right? Make it 8 to the 1/3, which just means what's the third root of 8? Right? So that would be 2, because 2 times 2 times 2 is 8. So there you go. The answer is 1/2. All right. So let's get into some examples for today. We're going to be using a bunch of algebra and using those exponent laws we talked about. Okay, so write down as many of these as you want. Really follow along. I'm going to go through a whole bunch of different examples, and hopefully by the end you start feeling a little more confidence to try some. All right, so let's get into the notes. Simplifying expressions using exponent laws. And it's basically we're doing questions like that last recall example I just did. Really, that should have belonged more in here, but let's get doing some of these. Okay, so we can use exponent laws when we have the same base. So we have 3 to the 1/2 times 3 to the 5/2. Sorry, the numbers are a little blurry there. But we're multiplying, right? So what can we do? We can add the exponents, right? So this would be 3 to the 1/2 plus 5 halves. So this would give me 3 to the 6 halves, right? Which would give me 3 to the 3, which would give me 27. There you go. So I'm using my exponent laws. This next one here, these do not have the same base, the 2 and the 5, so we cannot add their exponents. So we're stuck. But now what we're going to do, we're multiplying, so we're okay. We are going to multiply the exponents using the power of a power rule. So let's be careful here. I have a -2. Notice I kept the bracket around the negative. To the 2/3 times 6, right? So what's 2 times 6 is 12 over 3. Times 5 to the -1/2 times 6. So -6 over 2. All right, so let's reduce those exponents, right? So some people might start going, oh, I'm going to do the 3rd root and then to the power of 12. No, reduce your fraction first, right? Let's make the number smaller. 12 divided by 3 is 4. And -6 divided by 2 is -3. All right, so now we can simplify this. Again, these are different bases, so I can't add the exponents. So we're just going to evaluate it. Well, what's -2 to the 4? -2 times -2 times -2 times -2, right? So it's going to give me positive 16, right? Times 1 over 5 to the 3, right? That negative exponent means to flip it. So this is 16 times 1 over 125. Can't reduce that, so it's just 16 over 125. All right, let's check out another one here. All right, so what do you want to watch out for in this one? Okay, so basically, once we start doing the algebra here, what we want to do is rewrite this radical as an exponent instead, okay? So what do I mean by that? Let's rewrite it like this. So let's make this into 2. I'm going to kind of do baby steps here. There's the 2 to the 8. There's what's underneath, right? The radical 3, right? Let me just make it clear, right? If I have this, the 3rd root of x, right? That would mean x to the 1/3. So I'm going to rewrite this as 1/3. Now, if you want, you could just put it together with the 8 right away and just make it 8 over 3. But that's what that means. All to the power of this exponent on the outside, which is -1/2. So what are we doing here? Everything's just a power of a power. So if everything's just a power of a power, we can just multiply all the powers together, right? So again, you don't necessarily have to show it in as many steps as I'm doing. I'm just trying to really break it down here, right? And show you that I'm going 8 times 1/3 times -1/2, right? Well, we can reduce the 8 and the 2, right? Shrink this down a little bit. 8 divided by 2 is 4, right? So I end up with 2 to the -4 over 3. Now, this is not going to work out very nicely. This is going to be a decimal answer. So we could kind of stop there, or we could even write this. I don't think we're going to encounter anything like this in our textbook. This is what I get for just making up an example on the spot here. I don't even know where I got this example from. It's not a very good one, right? Because if I flip it, okay, I'd get that. And then what would we get from that, right? Well, you could do the 3rd root, right? 1 over the 3rd root of 2 to the 4. And what's 2 to the 4 is 16. That's as far as I can get it without getting a decimal. So this is a pretty ugly answer. I don't care for this one very much. But the main thing was showing you that we can multiply together all these exponents, right? All right, let's move on and check out some more. All right, so now we're getting into more pure algebra, and this is where this stuff is going. This is really the stuff we want to be able to tackle. So we're into some basic starter ones here. Look at the x's, right? Same base on the x, same base on the y's. We're dividing, so we can subtract exponents. So I can go, all right, what's 2 minus -3? And what's y to the 1/2 minus 1, right? Because that's an invisible 1 on that. So that's going to give me x to the 5, and y to the 1/2 minus 1 is -1/2. So now we got to decide how to write it. Some textbooks like the answer written like this, right? Some textbooks, now again, you're like, well, what do I pick? I just want to walk you through all the different ways of, basically we've simplified as far as we can, right? There's one x term, there's one y term. So don't get too hung up on the different ways, but some accept it like this. Some professors say it's unacceptable to leave your answer with a negative exponent. So instead, we would write it like this by flipping it, right? There you go. So you write it like that. We could also, I wouldn't go this far, but you could also say, well, what is 1/2, right? It could be written as the square root of y. So all three of these that I put a box around all mean the same thing, right? Just 3 different ways of writing the final solution. All right, let's check out the next one. The main thing is let's get it down so there's one x term and one y term, right? We got x's over here, x's over there. Now, following along on your handout, right? It might be hard to see the notes, these on the screen, but there's invisible ones there, right? So I'm going to use my power of a power law to multiply exponents. Okay, so we got x to the 1 to the -3, so now it's x to the -3, and I'll keep some brackets around this for now, and y to the -3 halves, right? And then over here, 1/2 times x to the -2 gives me x to the -1, and 1 times 1/2 is y to the 1/2. All right, now what can I do? Well, we're multiplying, so we can add the exponents. So I'm going to add the exponents on the x's, -3 plus -1, and y to the -3 halves plus 1/2. All right, so obviously -3 plus -1 gives me x to the -4, and -3 halves plus 1/2 is -2 over 2, right? So it's going to give me -1. All right, now again, some textbooks say, you can stop here. But most professors I've encountered in most of my life, I've always rewritten everything with a positive exponent. So I would strongly suggest you rewrite all your answers, at least with a positive exponent. So there, it's 1 over x to the 4 times y. Now, my tip for you when you're doing these algebra questions is this. Don't flip anything. See these negative exponents? I didn't start flipping anything at all till the very end. Wait till here. And then go, all right, I have one x term, one y term, they're negatives, then I'm going to flip it. Same with this. Notice I didn't flip anything. There's a negative over here. I didn't flip it yet. I waited till I had one x term, one y term, and then I simplified the negative exponent. Okay? So wait till the end. All right, let's do another one here. Now, this radical, it's generally a good idea as you're simplifying these to rewrite these as exponents. So this would really be to the 1/2, right? That's what that symbol there means. All right, let's multiply inside. 12 times 3, okay, that's pretty easy. That's 36. Now we can add the exponents on the x's. There's an invisible 1 there. Add the exponents on the y's. So we have 5 plus 1 is 6, and -3 plus 0 is just y to the -3. All right, now let's apply that 1/2 to each of these, right? So 36 to the 1/2. Don't forget, the 36 has an invisible 1 on him too, right? So this is 36 to the 1/2, 1/2 times 1. 6 times 1/2, well, 1/2 of 6 is 3. And that should be a y. And y, -3 halves, right? -3 times 1/2. All right, so how can we clean this up? This is okay, but 36 to the 1/2, what does that really mean? Remember, that means the square root of 36. So we can rewrite that as 6, right? So I could write it like this. So you might see it written like this in some textbooks. But generally, again, we shouldn't leave anything with a negative exponent. So what I would suggest you to do is this. These two guys stay where they are, but that negative exponent means he's in the wrong spot. We just flip him to the bottom and leave it like that. All right, there you go. So that would, to me, be the best way to write it. You could even go crazier if you wanted. I wouldn't and do this. You could say, well, remember, the denominator tells us it's 2, so it's going to be the square root. So you could actually do this and make it the square root of y to the 3. So you could write it like that too. 3 different ways of getting the same answer, right? All right. Okay, so let's move on. Check out a few more. All right. I know this video is a little long, but I really want to go through a whole bunch of different examples. So then when you start trying the homework, I've hopefully covered all the different bases that you'll encounter. All right, jumping around a little bit. I'm going to jump back to another example that's just all numbers, right? I got 27, 125. I got no variables in here, so this is no algebra, just purely arithmetic, right? All right, so let's go through this one. This one is a good one that, you know, I used to put on tests in your, usually when I used to do this unit, we used to do a smaller test on all small kind of numbers, but with no calculator to make sure you actually knew how to evaluate it. So like one like this. This is a perfect test question. Now, obviously, you got a calculator at home, but you still need to understand how to evaluate this without a calculator. So, first mistake people make, they multiply these two negatives. You just broke bedmass, right? Bedmass. You have to do what's inside the brackets first. All right, well, I can't reduce 27 and 125 for a stack there. Next step, exponent. We need to look out at this exponent here, and the first thing I see is this negative right here. So that tells me I need to take the reciprocal, right? So I'm going to flip this fraction, okay? All right, so what does that become? It's going to look like this. Keeping the negative out front, I'm going to flip this. The negative can just stay out front there. Doesn't matter. There we go, to the 4/3. All right, now, what's the next thing I'm going to do? Well, I got to keep working with this exponent. Remember, I always deal with the denominator of this first. So this tells me the index of the root, right? So we are going to find the third root of each of these. So in other words, what does that mean? Let's just put the negative with the 125 on top for now. We need the third root of negative 125 and the third root of 27. Sorry, I'm getting a little sloppy here. And then we're going to do that to the power 4 when we're done. All right, so what's the third root of 125? So what number times itself 3 times gives you negative 125? The answer would be negative 5. Negative 5 times negative 5 times negative 5 gives you negative 125. Same on the bottom. What about the third root of 27? That would be 3. All right, so I'm cleaning it up here. We're almost done with the exponent, except now we're going to apply this and go, well, what's negative 5 to the power 4 and what's negative 5 to the power 3? So we have 4 negatives there, so that makes that into a positive, right? And 5 times 5 times 5 times 5 is 625. And 3 times 3 times 3 times 3 is 81. And then there's a negative up front, so don't forget, this is now positive in the brackets. So our final answer is going to be negative 625 divided by 81. So that's like a, I don't know, not famous, but how about an infamous quiz test question from me, right? I took that right off of a previous test. So there you go. Here's another one. I'm just looking at some test questions that I grabbed here, for example, 3 that are really common that I like to use. All right, so right off the bat, this one's more about algebra and some arithmetic mixed together, right? We've got the variable f here. So first thing, I see this radical with a 5th root, right? I'm going to rewrite that as 1/5, all right? Now let's work inside the bracket for a little bit. I have 8 with an invisible 1, a 2 with an invisible 1, and we need to apply this 10 to each of them, right? We have to multiply using our product rule. So this is going to be 8 to the 10, and multiply by the negative 1. Negative 1 times 10 is f to the negative 10. Now don't calculate what 8 to the power of 10 is right now, just leave it. All right, so now let's do the next one. What's 2 to the 1 and f to the negative 3 times 5? So that gives us 2 to the 5, and f to the negative 3 times 5 is negative 15. Now some of you might be a little clever here and think, hey, I could rewrite 8 to the 10. You could actually get away with doing this an even shorter way, right? Because 8 to the 10, well, isn't 8 just 2 to the 3? So you could rewrite it like this and then make this 2 to the 30. So if you wanted this 8 to the 10, you could make it 2 to the 30 if you want to get really fancy, and then subtract the exponents on those guys. Here's what I'm going to do instead. I can work with these f's at this time, or everything here is divisible by 5, right? So I've got a 5 on the outside. So if I want, you know what I could do also? I could just apply this 1/5 to each of these. Multiply everything by 1/5, all the exponents, right? So what do we get? Well, 10 divided by 5 is 2. Negative 10 divided by 5 is negative 2. 5 divided by 5 is 1. And negative 15 divided by 5 is negative 3. So I just shrunk everything down. And let's calculate this. 8 squared. Now that's easy to calculate, right? 8 squared is 64 divided by 2, right? And what are we going to do? Oops, hang on here. 64 divided by 2. And what are we going to do with the f's? We're going to subtract them. Negative 2 minus negative 3. 64 divided by 2 is 32. And what we're going to end up with is negative 2 plus 3, which is f to the 1. So there you go. You end up with 32. Now, like I was saying earlier, for those of you who are being a little clever and you think, hey, I could have rewritten this 8. You could have done it right at the start and rewritten 8 as 2 to the 3, right? What would it look like if we did it that way, right? I'd have 2 to the 30 divided by 2 to the 5, f to the negative 10 divided by f to the negative 15. So if you're thinking about going a different route, let me compare, right? I could have done this instead. I could have, since these have the same base now, subtract the exponents and make this 2 to the 25, right? Negative 10 minus negative 15 gives me f to the 5. And then multiply them each by 1/5, which would give me 2 to the 5 and f to the 5 over 5, right? So 1, which would give me 32f also. So kind of 2 ways about going about it. So sometimes you can kind of find little shortcuts in these and different ways about going about them. All right, let's check out a little more. Okay, I got example 4 here. I got a couple more in this group. Back to, again, having a mix of some algebra and some arithmetic. Now, don't forget, this 2 has an invisible 1 on it, this 3 has an invisible 1 on it. Same with over here. I'm going to write the 1 on the x, the 1 on the y. If you don't see an exponent, it has a 1, and it's usually a good idea to write those in. Now, we got to deal with these exponents on the outside before we can start subtracting the exponents on the inside, okay? So we can't do this division until we deal with these exponents. So multiply all your exponents, right? Multiply the top, multiply the bottom. What are we going to end up with here? I have 2 to the 5, x to the negative 15, y to the 20, right? Multiply over those. I got 3 to the 2, x to the 10, y to the negative 4. Now, obviously with the x's and y's, I can subtract their exponents, but the 2 and the 3 don't have the same base. So people always stop there and they quit. You just evaluate it. What's 2 to the power of 5? 2 times 2 times 2 times 2 times 2 is 32, right? What's 3 to the power of 2? It's 9. It's 32 over 9. Can't do anything else. The x's, though, we can subtract them. What's negative 15 minus 10? The y's, we can subtract them. What's 20 minus negative 4? All right, so I end up with 32 over 9 times x to the negative 25, y to the 24. Now, we need to clean this up a little bit. Basically, the simplest way to write this is the y stays on top because it has a positive exponent. The x term moves to the bottom because it has a negative exponent. We drop the negative. So there you go. You have 25 x's on the denominator, 24 y's on the numerator. All right, next one here. I'm going to rewrite this 0.25 as 1/4. I'm going to work with the fraction instead. So I'm going to apply this to each of these, right? And then apply this to each of those guys there by multiplying. So what are we going to end up with here? We got x to the 1/4, y to the 2/4, which is 1/2, times, I'll keep the bracket around it for now, x to the -12, y to the -3. Okay, now we're multiplying the bases so we can add the exponents. So 1/4 plus -12, right? We want fractions, and we're in grade 11 here. We can handle fractions. If you can't get a common denominator at this point, you could be in a bit of trouble, right? And 1/2 plus -3. All right, so let's get a common denominator, right? That's over 1 times it by 4. So I got 1/4 minus, what do we got? 48 over 4. So that's going to give me x to the -47 over 4. So again, I want you to get fractions. Anytime you see decimals, convert them to fractions, okay? And 1/2 minus, right? We're going to times that by 2 and times that by 2, 6 over 2. So that gives me y to the -5/2. Again, they're both negative, so the proper way to write our solution is we should flip it to the bottom and write it like this. There you go. Not the prettiest answer, right? Kind of ugly numbers, but we're going to encounter some that aren't that great. This one is just basically, what am I testing you on if this was on a test, right? I think I took this off an old quiz. Just basically, can you work with fractions, right? The quiz said, make sure you rewrite any decimals as a fraction. Make sure you can get a common denominator. That just basic stuff, right? All right, one more little group, and then we're all done here. Okay, so here's our final group of questions for this lesson. It's less of a lesson of me just walking through lots of examples because it's hard to do a real lesson on this once you've learned the rules, right? You have to practice it yourself. So I'm just trying to throw a little of everything at you to get you comfortable with it. All right, so what can we do here? Well, in this first guy here, right, I got a radical, and it's always a good idea to rewrite this as an exponent. So what we can do is instead, here, I'll just write a big bracket here, right? Right, this would be 4 over that 3 would be on the denominator, right? Because it's 4 times 1/3. Okay. Now, inside the bracket, can we, you know what? I'm going to change this question. I think this was supposed to be an A on the bottom, and I can see it's a B. I think I did a little typo. So let's just rewrite that. I'm going to cheat a little here and make that an A instead, all right? That's an A to the 4. All right, so 64 and 216. That can be reduced. So we still want to use the old scales that we had. Like, we still should reduce anything and everything we can. I can divide them both by 4. I think I can divide them both by 8. So let's reduce this fraction here. Let's make this 8, and 216 divided by 8 is 27. Yep. Okay. Now, the A's, since I changed that B to an A, right, I can subtract those and just make this A to the 2. All right, so we've reduced it substantially, right? All right, so let's see what we can do now. Now I'm probably regretting rewriting. I guess this is one of those times that maybe it wasn't a good idea to rewrite because I want to apply this third to each of these, right? So in other words, what's the third root of each of these here, right? So let's do that. What's the third root of these? Well, what's the third root of -8? What times itself 3 times gives you -8? It would be -2, right? Now, A to the 2, well, that would be A to the 2/3, right? And 27, what times itself 3 times gives you 27 is 3, all to the power of 4. So I still have to apply that 4. So now let's apply the 4 to each of these, right? What's -2 to the 4? What's A to the 2/3 of the 4 and 3 to the 4? All right, so -2 to the 4, -2 times -2 times -2 times -2 is positive 16. 3 to the 4, 3 times 3 is 9, times 3 is 27, times 3 is 81. And A to the 2/3 of the 4, we can't simplify that. We'll just multiply it. 2 times 4 is A to the 8/3. And that's as simple as that's going to get, right? So we simplified as much as we can. Again, not a great example. I think I must have written this out a little wrong because I wanted to work it a little nicer, but the rules still work out there. All right, last one. This one, you end up with, you're going to encounter a question like this, and people freak out, and they're like, I don't even know what to do. This goes right back to when you're first learning exponent laws. We have the same base of A. What can we do with the exponents? This is it's probably the simplest question of the whole group. Just add them, but I just slipped them in at the end, okay? So what is 10 plus 3c, I'll just put brackets around that, plus -2c minus 7. So all we're doing is just simplifying the exponents, right? Well, let's get the c's first. 3c minus 2c is 1c. 10 minus 7 is 3. There you go. Here's your answer. Can't simplify it anymore, right? So I just want to slip those last couple guys in there. All right, so you got some textbook questions to try. Make sure you try them out, and ask lots of questions if you got them. Okay, don't wait till the last minute.